Amongst the buzzword soup of the modern IT industry, you'll often find Kubernetes and Docker getting mentioned alongside fellow buzzwords like cloud and DevOps. But what are these Kubernetes and Docker things all about, and how might they be useful? The short version is they're about containers. Kubernetes is for orchestrating containers at scale. Docker is a platform for creating and running containers. And what are these containers? The topic of this video. Welcome back to the Pro Tech Show. This video is a high-level introduction to containerization. Docker is largely responsible for popularizing the use of containers, but Docker didn't invent containerization, nor is it the only platform for them. You can run Docker on both Linux and Windows, so as most people probably think of Linux first when containers are mentioned, they are by no means limited to that. Containers can benefit both developers and sysadmins, but the developers are usually the ones banging on about them, so let's look at them from the application perspective first. Then we'll talk about the infrastructure. A modern application isn't a self-contained blob, it is a whole web of dependencies and libraries that it relies on. These libraries save a huge amount of time when developing software because you don't have to keep constantly reinventing the wheel, but they can also create a whole mess of problems when moving from one environment to another. The classic scenario is that the developer hands over some code to operations, they deploy it, and it immediately crashes and destroys itself. What does the developer say? Well, it worked on my computer. Of course it did. But obviously your laptop and the server we're actually running it on differ somehow. Maybe the operating system is similar, but not exactly the same. Maybe one of those libraries is a different version, or part of the application conflicts with something else already on the production system. Or maybe you had it all working fine, and then you updated the underlying infrastructure and that caused a change which broke the application. Maybe it introduced a bug, or maybe it fixed a bug, and the application was relying on that bug. Sounds silly, but believe me, that happens. Containerization attempts to solve this problem by taking the application and all of its dependencies and then packaging them up into one self-contained box, or container if you will. The idea is that this container contains everything the application needs to run, and you can deploy it as a single unit with whatever version of PHP or .NET or whatever it needs as part of the same package. You just need an operating system that's capable of running the container. As long as it can run the container, everything should work predictably, regardless of where it's deployed, because it is everything it needs inside the container with it. This is not just about dependency resolution like you get with a package manager on Linux. The whole thing runs inside its own little bubble. Because it exists in its own little bubble, different containers can run the same host and have completely contradictory and conflicting dependencies, but they don't interfere with each other because those dependencies are walled off inside each application's container. Because containerization runs applications within their own isolated bubbles, and many of these bubbles can run on a single host independently of each other, it often gets compared to server virtualization. Containers and virtual machines are fundamentally quite different, but you could think of containerization as a type of virtualization that occurs at a different level. If virtual machines are virtualization of the hardware, then containers are virtualization of the operating system. It helps if you view a server as a series of layers built one on top of the other. At the bottom, you have the physical nuts and bolts hardware. Running on that hardware, you have an operating system like Windows or Linux. The operating system can be further subdivided into the kernel and supporting applications. On top of that, you install your own applications. Server virtualization puts a layer called a hypervisor in between the hardware and the operating system. This hypervisor pretends to be multiple copies of the hardware. These are your virtual machines. This lets you install multiple operating systems, one in each virtual machine, letting your one piece of real hardware host multiple independent servers, each with their own copy of Windows, or Linux, or BSD, or whatever you want, and each with their own applications installed. Containerization happens a layer above that, so rather than sitting between the hardware and operating system, it sits between the operating system's kernel and the applications. Instead of pretending one set of hardware is actually multiple sets of hardware and letting you install multiple operating systems, it pretends your operating system, or more specifically its kernel, is multiple operating systems, which allows you to run multiple applications, each thinking they've got an operating system all to themselves. They're all sharing the same operating system kernel, but they don't know that. Because it's using the same underlying host operating system's kernel, the containers do need to be compatible with it, but it still affords a fair level of flexibility. You can't simply run a Windows container on Linux or vice versa, but you can mix containers from different Linux distributions. For example, you can run an Ubuntu container on Red Hat, as long as the underlying Linux kernel and architecture is compatible. Compared to server virtualization, containerization has some advantages at an infrastructure level, the main one being that the container is much smaller than a virtual machine. A virtual machine has to encapsulate the entire server, including its operating system. Because a container shares that with other containers on the host, it only needs to include the application layer. That means that containers take up less storage compared to virtual machines, and they incur less resource overhead, because you're not running multiple full operating systems. The end result is that you can pack more applications onto the same hardware using containers than you can with multiple virtual machines. This is cost and scalability benefits beyond what you get with server virtualization. Both technologies allow you to scale out very quickly by deploying new instances, but containerization can do it much faster, because starting a new container only takes a few seconds, as it doesn't need to wait for an operating system to boot. Remember how going from physical servers to virtual servers reduced the start time significantly? Well, this makes it faster again. In fact, it's so fast that fault conditions are often dealt with by just discarding the running container and starting a new one. These features make containerization a natural fit for applications deployed using a microservices architecture, where the application is broken down into a number of smaller and simple components that can each be packaged into their own container. Scalability and fault tolerance are achieved through the ability to deploy, redeploy, and move containers around different hosts. So why aren't all applications deployed using containers? Well, not all applications are a good fit. You know I said microservices were a natural pairing? Well, the opposite of microservices, being a large monolithic application, is usually a bad idea to containerize. Some would argue you can containerize most applications if you try hard enough, but ideally you want to be developing the application with containerization in mind, and large complex applications really need some level of rewrite if you want to move to containers. If you're a developer working on your own software, that might be an option, but for most people using off-the-shelf products, well, it's not like you can just download SharePoint and install it on a container. They're also not well suited to applications with graphical interfaces. There are some scenarios where this can be made to work, but it's limiting, and it may require clunky workarounds, and it's just not what they were designed for. Containers are more for back-end services that users don't interact with directly, or if they do, it's via some other application like a web browser. Whilst it's a different technology, it is fair to suggest that they've at least inspired ideas like flatpak applications though. Security is also an area of concern when it comes to containers. Because they're sharing a single operating system, that host operating system can see everything. If you run a process in a container, you're running it on the host operating system, and anyone with access to that host can manipulate it. It also increases the risk of lateral movement between applications should an attacker exploit a vulnerability to escape from the container and gain access to the host. Remember that it's actually the same operating system underneath. Containers aren't as self-contained as virtual servers, and thus don't benefit from the same security isolation as virtual machines do. This might not be a big worry if you're running your own containers on your own hosts, and containers with different security levels are never allowed to mix. But it has very serious implications for shared platforms like cloud providers, where random people could be running their code within the very same operating system instance as your sensitive data. Before you run away from the cloud screaming in terror, there are solutions to this problem. The big names will be using such a solution, but don't be afraid to ask the smaller providers how they guarantee isolation between customers, because there are some cowboys out there. We have in fact talked about a solution to this security concern already: virtualization. There is a middle ground between full-blown virtual machines and containers, which essentially wraps containers inside lightweight virtual machines. This provides your container with the same security isolation that virtualization provides, whilst maintaining the portability benefits of containers. Because the container is encapsulated inside a virtual machine, that VM doesn't need to match the host operating system, so you can even use this approach to run Linux containers on Windows. Whilst this might sound like a best of both worlds thing, it's really a trade-off. You do lose some of the efficiency benefits of containers compared to virtualization once you deploy containers inside virtualization. You don't lose all of it though. The virtual machines used to run containers are more specialized. You don't need to load a full instance of Ubuntu if all you want to do is run a container in it. These virtual containers use more lightweight single-purpose virtual machines that start faster than a normal VM and incur less overhead. But they're still a bit slower and more bloated compared to a traditional container. It does give you more options though. It allows your developers to build their applications in containers for portability, and then your ops team can decide later if they'll be deployed as native containers for better performance, or virtualized containers for better security. Now that I've mentioned both dev and ops in the same sentence, this leads me to a bit of a cautionary thought. I don't personally use containers very much, but I think every IT professional should at least understand what they can do and where they might be useful. DevOps is an example of where they work really well. We can use their portability to streamline the journey from developer to production. It's a great use case for them, but it's not the only use case. I've heard people advocating the use of containers because it means you can deploy complex applications without needing to know anything about how they're put together. People with little or no infrastructure experience use them to deploy services on their home NAS, for example, stuff like Plex or Bitwarden. Whilst that is very convenient, it also worries me a little. Actually, not that use case, it's okay. I generally like anything that gets people experimenting with tech, but when the same attitude makes its way to production, when people are deploying business-critical services with no idea how they work, I consider that a problem. DevOps is fine, but take the ops out of it and you've just got developers. This isn't a dig at developers. Writing software and securing infrastructure are different skill sets. Some of the developers I work with know more about IT infrastructure than a lot of IT pros, but they're in the minority. I've spent far too much of my professional life pulling vendors up for distributing their software with serious security vulnerabilities resulting from third-party dependencies. The problem is that developers often don't understand how these work. They just know that by including this library, they can get their code working. The perfect example of this is the Log4Shell vulnerability that probably ruined a few of your Christmases. I use an application that was vulnerable to this. One of the ways that application can be deployed is as a container. At the time of recording this video, it is January 2022, and the containerized version is still vulnerable. I didn't deploy it as a container, so I was able to quickly remediate it myself. But if I was running it in a container, I would be reliant on the developer, and that would put me in a rather precarious position. If you're going to consume applications in the form of containers that are being developed by a third party, then make sure you do your due diligence on that third party. Because whilst in theory it makes the process of deploying updates much easier, this only counts if they're actually providing timely updates, including those packaged up dependencies. If they're not doing that, it could actually put you at higher risk. That's not a problem with containers themselves, it's a problem with people using them badly. Just because you can deploy something without understanding it doesn't absolve you of your duty to deploy it responsibly. As I said, I don't really have much of a use case for containers myself at the moment. I just like to know what my options are so I can pull them out of my toolkit when they're needed. If you want to explore this topic further, I do have an industry expert in containerization who's happy to come talk to you, so go down to the comments and let us know your questions and we'll build some content around that if it's something you want. If that video has already gone up, you'll be able to click on it here. And if not, I'll let YouTube's algorithm find something interesting for you to watch instead. Hit like if this was useful, and I'll see you next time.